Hi, how's it going? Welcome to Code with Z. In today's video, we have to find the maximum product subarray of this array that we have here. Why? Well, because that's what LeetCode 152 maximum product subarray is asking us to do. As you can see, it says, given an integer array called nums, so for example, this array that we have here, find a subarray that has the largest product and return that product. Okay, let's see what the subarray and the product mean. Well, a subarray can be 2 and 3, or it can be 2 and 3 and minus 2, but it can't be 2 and minus 2 because there's 3 between them and we did not include it. So the subarray can be any part of this array as long as we include all of the numbers that are between them and there's basically no space between them. They have to be stitched together. So for example, 2 and minus 2 is not a valid subarray, but minus 2 and 4 is a valid subarray. However, for example, 3 and 4 is not a valid subarray. And for the product, for example, if we pick 2 and 3, so if our subarray has 2 and 3, the product is 2 multiplied by 3 and that's going to give us 6. But for example, if we pick 3 and minus 2, the product of this subarray is going to be 3 multiplied by minus 2 and that's going to give us minus 6. And we have to find the maximum product subarray. So let's see how we can solve this. We're going to need 3 simple variables and then I'm going to visualize the whole process so you can see how things work with your own eyes. The first one that we need is going to be called maxProd, and this is going to be basically representing the maximum product that we can find, and this is going to be initialized to the first value that we have here. So for example, the first number here is 2, so maxProd is going to be equal to 2. The next thing that we need is going to be a variable called currentMax, and this is going to be also initialized to the first value, and then we're going to have currentMin, and this is going to be also initialized to the first value. Now don't worry if something is foggy, we're going to literally have a visualization and you're going to see how things work. Now that we have our 3 variables, let's see our simple rules. The first one is that if the current number is negative, meaning if we loop through this and our current number is negative, swap currentMax and currentMin with each other. And this happens because we're looking for the product, right? So we have multiplication. And once we actually multiply our current number, which is negative, by our currentMax, it's gonna flip the value. So the currentMin is gonna become positive and the currentMax is gonna become negative. So because this actually flips the values, we have to also flip the value as well. So we actually swap currentMax and currentMin. Now again, if something is not fully clear, it's normal. You're gonna see how things work in the visualization. Our second rule is really simple. We're gonna say set currentMax to the maximum of current and current multiplied by currentMax. So you basically get the maximum value between the current value that we have for our currentMax and current multiplied by currentMax. That's going to be it. Same thing for currentMin, but we're going to check for minimum. We're going to say currentMin is equal to the minimum between current and current multiplied by currentMin. And then last rule is that we're going to update maxProduct, as you can see, maxProduct to the maximum between currentMax and maxProduct itself. Now let's start the visualization. We're going to start with the second element. Why? Well, because we've already taken care of the first element when we initialize all of these to be equal to the first element. So we start from the second element in our array and we're going to start looping. We're going to check our rule. We're going to say if the current number is negative, swap it. Well, it's not negative, so we're going to ignore this line entirely. And then we're going to say set currentMax to the maximum between current, which is 3, and current multiplied by currentMax. Maximum between current, which is 3, and current multiplied by currentMax. So the value is 2, meaning currentMax was 2, so therefore we have 3 multiplied by 2. This is going to give us 6. Maximum between 3 and 6 is going to be 6, so currentMax is 6. And then we're going to say set currentMin to the minimum of current and current multiplied by min. Again, same thing. The minimum between 3, which is our current value, and the previous value multiplied by the current. That's going to give us 3 and 6. We're going to pick the minimum and that's going to be 3. And then we're going to get to the fourth rule. We're going to say maxProduct is equal to the maximum between currentMax and maxProduct. Well, let's see max between 6 and 2. That's going to be 6. Now maxProduct is 6. And now we're going to move on to the next round. In this round, we're going to have, again, the same thing. We have to follow these 4 rules each time. We're going to say if the current number is negative, well, yeah, it is. Swap currentMax and currentMin. Well, let's swap them like so. As you can see, we swapped them. And then we say set currentMax to the maximum of current and current multiplied by currentMax. Again, maximum between current, which is minus 2, or minus 2 multiplied by 3. And that's going to be minus 6. The maximum between these two is minus 2. And then we're going to pick minus 2. And then we have to find the minimum for our currentMin. So let's find the minimum between current and current multiplied by currentMin. So minimum between minus 2, which is our current number, and current number multiplied by our current minimum. So minus 2 and minus 12, we're going to pick the minus 12 because we want to look for minimum. So we're going to pick minus 12 and then we have to update our maxProduct. we're going to say max product is equal to the maximum between current max, which is -2, and the max product itself. So it's going to stay as it is because it was 6 already. And then we're going to move on to the next round. In this round, again, we're going to have the same thing. We're going to say if the current number is negative, swap. It's not, so we're going to ignore this line entirely, and then we have to calculate our current max, which is equal to the maximum value between current and current multiplied by current max. So maximum between 4, which is our current number, or 4 multiplied by -2. That's going to give us -8, and now current max is going to be equal to 4. And then for this one, set current min to the minimum of current, or current multiplied by current min. So this is going to be 4, which is our current number, or -12 multiplied by 4, and that's going to give us -48. Between these two, -48 is smaller, so we're going to pick this number as our current min, and then we have to update our max product. And it's going to be equal to maximum between current max or max product. Well, 6 and 4. Maximum between 6 and 4 is going to be 6, so it's going to stay as 6. And then we're going to move on to the next round, which is our final round. And then we're going to check again if the current number is negative. It is, so you have to swap them. Swap what? Current mix with current min. So let's swap them like so, and then we have to follow the rest of the rules. So the second rule says we have to find the maximum value between current and current multiplied by the current max. Well, that's going to give us -5, which is our current number, or -5 multiplied by -48. And once we do this, we get 240, and the maximum value is gonna be 240. That's why we have to swap the values each time, because the negatives always flip the values. So we have to make sure that we swap our values each time we have a negative, so we have these correct calculations that we just had here. And then same thing for current min. It's going to be the minimum between current and current multiplied by current min. Well, our current number is -5, and then -5 multiplied by 4. That's going to give us -20 as our current min. And then we have to update our max product, and that's going to be the maximum value between current max and max product. So maximum between 6 and 240. We're going to pick 240, and that's going to be it. And then we're going to be done with our loop, because we went through all of the numbers that we had here. After we're done, we're going to simply return max prod as our final answer, and that's going to be it. Now let's code this in the simplest way possible. Alrighty, let's code this together. So just like we saw in the slides, we're going to need our 3 simple variables. So let's define them. We're going to say let max prod be equal to the first element inside of our nums array. So nums at the index of 0, and then we're going to say let current max be equal to nums at the index of 0 as well. And then same thing for current min, nums at the index of 0. And then we have to go through our numbers. So we're going to need a loop. We're going to say for let I being equal to 1, because we want to start from the second element. And then we want to keep on looping as long as I is smaller than nums.length, and then I plus plus. Here we're going to say const current is equal to nums at the index of I. So this is going to give us our current number. And then we're going to have our 4 simple rules. The first one is that we're going to say if current is smaller than 0. So if it is negative, we have to swap. And this is how we do swapping in JavaScript. We're going to say, so current max and current min should actually be current min and current max. So this is how we do swapping in JavaScript. So our first rule is done. Let's go to the second one. We're going to say current max is equal to the maximum value. So math.max between current and current multiplied by current max, like so. And then we're going to have something similar for current min. We're going to say math.min this time between current and current multiplied by current min. And then lastly, our last rule was that we're going to update our max prod to be the maximum. So math.max between current max and max prod itself. And then at the end, we're going to return max prod. Simple as that. Now let's run this and see if we can actually get accepted. Let's see, and we got accepted. Now let's submit this and see if we can actually pass all of the test cases. And yep, we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe, and keep on coding.